All right, good morning, good evening, good afternoon. Welcome back to the channel. This is Slope Part 2, where we're going to go a little further with the slope formula and try out some more examples and test questions. If you have not yet seen Slope Part 1, make sure you watch that video first. This video was a request from viewers. Feel free to make a request for what you want to see next in the comments below. Feel free to leave comments with any kind of question. Feel free to say, "Good job, Mr. Leo. I like your channel." The more you engage, the better it is for us. And please, if you like what you're watching, send this to someone who would also like that video. Do you have your notebooks? Do you have your notebooks? You need to be writing down to get the most out of this lesson. If you need to, pause the video and go grab your notebook and a pen or pencil. All right. Slope Part 2. This is where we left off in Part 1. These are all the definitions. This is a pretty crazy page. I made this page. This is everything I could tell you about slope in one place. Let's briefly review. The slope of a line, or the slope of a linear function, the definition is visually, slope is a measure of steepness. Slope is how steep is the line. Mathematically, slope is the rate of change of a linear function. How much do the outputs change as the inputs increase? And in a linear function, slope is the multiplier. If your linear function is 3x plus 5, the multiplier is 3, the slope is 3. Slope is the multiplier. You can ask yourself, if you have a graph, how much does the line go up for every click forward? Slope is also known as rise over run, which can be written like a fraction, or it's essentially a division, rise divided by run. How much does it go up divided by how much it moves forward? This means vertical change divided by horizontal change, which is the output change divided by the input change, which is a change in the y value divided by the change in the x value. When we say how much does it change, you're essentially subtracting 2 points to find the difference between them. This is the slope formula. This takes you subtract one y value from another y value, and you put that over subtracting one x value from another x value. This is mathematically laying out rise over run. This is rise over run written thoroughly mathematically when all you have are a couple points. All right, let's go ahead. Let's practice this slope formula. All right, here we're going to find the slope of each line. We're going to use the visual method, rise over run. So look in here, look for any two clear points. I see a clear point here, and I see a clear point here. Rise over run, it looks like it's rising 1, 2, 3, 4, 5, and it's running 1. This would be 5 over 1, which would simplify to just 5. You could have counted all the way to the top. In this context, it would be rising, I believe that is 10, and then running 2. From that context, it would be 10 over 2. If you divide that, it is also 5. The slope of this line is a positive 5. It's going up 5 clicks for every click forward. All right, let's look at this number 2 here, down here. Notice here immediately, notice this slope is negative. It's going down. It's decreasing from left to right. I got one clear point here. All of these look like they're in the middle, so I don't want to use them. Let's use this one right here. That is going down 1 click. Down 1 click. So that's going to be -1. That is rising -1, meaning it's falling 1. And then it's running. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. This is -1 over 10. To finalize the answer, just pull the negative sign out front. I like to keep these as fractions. You could convert this to a decimal, but the fraction to me is more helpful because you can use it as a rise of a run. This means it goes down 1 over 10, down 1 over 10. So we often see these fractions here. They're helpful. All right, number 3, this is another negative slope. You can see it's going down from left to right. I see a clear point here. That's almost a clear point, but I don't trust it. I'm going all the way down here. So it looks like it's going to fall 1, 2, 3, 4, 5, 6, 7, down 7, and it's running 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. To finalize the answer, pull the negative sign out front. This is -7 over 10. That is the slope, -7 over 10. This means it goes down 7 over 10, down 7 over 10. Okay. Number 4 here, we got a point here and a point here. This one is going to be positive. It's rising. We'll count the whole thing. I see it as rising 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 over 1, 2, 3, 4. 10 over 4. This could be simplified. You could divide and get a decimal, but I like to use a fraction skill called reducing the fraction. We're going to divide the top number by the same thing, in this case 2. 10 divided by 2 is 5. 4 divided by 2 is 2. 5 over 2. If you were going to do this the other way, make a decimal, you would do 10 divided by 4. 10 divided by 4, you can check on a calculator, is 2.5. These are equivalent answers. 2.5 is the slope, or it's 5 over 2. So if I go back to the picture over here, and I look at the motion over here, you could say it's going up 2.5 for every 1, 2.5 for every 1. It's kind of hard to see, but from here to here, 2.5, up 1, 2.5. Oh, that'd be right here. Yeah, okay. Up 2.5. It's kind of hard to see. Or you can see it going up 5 over 2, up 5 over 2. Much easier to see when they're whole numbers. Okay, that's the visual method. Let's move on. Let's practice some more. All right. Here, you're going to tell me the slope and y-intercept for each equation. For right now, just focus on slope. What is slope in this context? Remember, slope is the multiplier. So in this case, the first one, the slope is 4. That's it. This one, the slope is a fraction, 7 over 4. That's it. We like fractions in this context. Down here, what's the slope? You tell me. What is it? It's 1/3. That's it. Over here, what's the slope? Do you remember this? What's the slope? Don't say negative x. Slope is -1. -1. You see the invisible 1? That means -1x. That's the special example. They don't often write the 1. You'll just see it by itself. There's an invisible 1 there. Here we go. What's the slope here? -7 over 5. What's the slope down here? That's 3 over 2. That's it. Slope is the multiplier. If they give you the equation, it's so easy. The y-intercept in these cases is just the other value, the constant. You just got to keep in mind if it's negative. So I'm just writing the information. This y-intercept is -10. This one's -3. You see what I'm doing? This one's -4. This one's 4. This one's -3. This one's +3. I'm just pulling the information out. But again, the slope is the multiplier. All right. Feel free to pause this and take a look if you need more time, but I'm going to keep on moving. All right, here we go. Here we go. Now you could find the slope here by doing rise over run. But before we do that, let's try the slope formula. It's written down here below. y1 minus y2 over x1 minus x2. I've seen these reversed. Sometimes the 2 comes first. It doesn't matter. And it doesn't matter which one you call 1 or 2, as long as you do 1 minus the other. So the art of the formula tells us before you start plugging in numbers, take your piece of paper and just copy the original formula. This is m equals, m being montrere from the French. That means mountain or slope, montrere. Okay? And now y1, y2. So I like to label these xy, xy. Every coordinate pair is x and a y. Now it really doesn't matter which one you start with. In fact, there's always 2 ways to do this, where you start with one number, like I could start with the 6, or I could start with the -4. Either way. But you have to put the y values on top because essentially we're breaking down the rise. We're looking for the vertical change. So do whatever you see. I like positive numbers. So I'm going to start by starting with this y. We'll start with this y, which is 6. I use a subtraction from the formula itself, and now I need the other y. It is a -4. I now have a double negative. I'm not scared of double negatives. If you're not confident with negatives, this is going to get weird. So take it for what it is. I have a whole video unit on negatives available if you need it. Now, here's where you no longer can choose what you want to do. I have to start with the x's, and you have to start with the corresponding x. You can't mix them up. Since I started with this one, I started with this 6 on the top. On the bottom, I need to start with the corresponding x, which is 3. Because I chose to start with the 6, I must start with the 3 down here. If you mix it up, it'll be a mistake. It's as if you're doing something else. So now, again, there is a minus sign from the formula itself. Then I use the other x value, which is -2. You must write out this step. If you do not write out this step, you're missing the whole point. Now, we have to apply our negative rules. This is a context where we simplify these double negative signs. If you hate to hate, you're a lover. So this becomes 6 plus 4 on top. And on the bottom, this becomes 3 plus 2. The slope formula definitely requires you feel pretty confident with negatives. Now let's finish it. On the top, 6 plus 4 is 10. 3 plus 2 is 5. I got 10 over 5. We're going to break that down with a division. 10 divided by 5 is 2. This is a slope of 2. This is a slope of 2. Prove it. Well, here we go. Up 2 over 1. Up 2 over 1. Every time it rises 2, it goes 1 click forward. Up 2 over 1. Up 2 over 1. That's it. That's it. Up 2 over 1. 2, 2, 2. It's increasing by 2 every time. Or, how about this? Let's do rise over run method for the entire line. To get from this point to that point, it would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Be careful with that. Don't count when you start. Count as you move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, that's 10. Rise. Now it runs 1, 2, 3, 4, 5. 5. Rise over run would tell us that this is 10 over 5. 10 over 5. That's what we got here. 10 divided by 5 is 2. Slope is 2. That's great. Well, you might say, Mr. Leo, why do we even use that formula? If I could just count the squares, why am I using the formula? Because sometimes there is no graph. That's the point. What I'm trying to tell you is, if they give you an equation, if they give you y equals 2x and ask you for a slope, that's the easiest one. The slope is 2. It's right there. If they give you a graph, you can work it out by counting out the squares, counting out rise over run. We got the slope is 2. But the hardest is when they don't even give you a graph. All they give you are a couple of coordinate pairs or a couple of data points. Then you kind of need to run this formula over here. You'll notice again the formula was actually very much related to rise over run counting out, except you don't have a picture. Okay, this is high level stuff, but is it making some sense? Are you making connections here? Let's move forward. All right, find the slope from the pair of points. Use the slope formula. This is what I'm talking about. Here, you gotta be good with your negatives. Okay, step 1, always write the raw original formula. Don't start plugging in numbers. It's too easy to make mistakes. Here's the formula. y1 minus y2 over x1 minus x2. Okay, it could have been 2 and then 1. It doesn't really matter. Now, let's plug in what we know. I like to always label these xy, xy. Okay. So start with whatever you want. I like to start with a bigger number that I see, but it really doesn't matter. I'll start with this number 4. So y value is 4. Subtract the other y value, that is 0. Double check that. This y minus that y. 4 minus 0. Good. Now on bottom, I do the corresponding x. I have to start with the 4 because I started with this 4. 4 minus the other number. Now notice there's a subtraction from the formula itself. The other x is a -3. This is a double negative. You see that? Subtraction from the formula and it's a negative 3, double negative. All right, this becomes 4 minus 0 is 4. This is a double negative. I'm going to rewrite that as 4 plus 3. To finish it off, I will have 4 over 7. That's a nice fraction. I like these fractions as slopes. They're often nice like that. You could convert to a decimal if needed. All right. All right, let's do this next one over here. Okay, let's start. Let's label everything XY, XY. Make sure you're doing this in your notebook. This technique you really have to practice so it comes naturally. Now, I like to start with the bigger numbers. It's up to you. But before we're doing that, write the formula. Don't be lazy. I know it's right there on the page. Trust me. Write it again. Okay? So I'm going to start with this y. That's going to be 5 minus the other y. That's a negative 5 over the corresponding x, which is 5 minus the other x. All right. This double negative becomes 5 plus 5. And 5 minus 2, that's 3. That becomes 10 over 3. Final answer. 10 over 3. All right. Nice job. Okay. Let's come down here and do number 3. Let's write the raw formula. Y1 minus Y2 over X1 minus X2. All right. Let's label these XY, XY. Feel free to pause the video if I'm going quick for you. Okay, so let's start with the y value. I'm going to start with the second one. That's a 4. So this y minus the other y, that's 4 minus 2. And down below, it's the corresponding x, that's this negative 2. Subtraction from the formula, and then I have a positive 3. And let's just double check here. Y minus y, that was y minus y, over x minus x. Good. All right, negative rules tell us this becomes 2 over negative 5. On the bottom here, this is same signs, add and keep. To phrase the final answer, I just pull the negative sign out front. This becomes negative 2 over 5. I think it's important to do that because this indicates that the whole thing is negative, which indicates this line is going down. If I was to graph this right now, I could do that because negative 2 over 5 means it's going to drop 2, run 5, down 2, over 5, down 2, over 5. So it's really helpful to have it in this format. All right, over here. Feel free, if you're feeling confident, pause the video, do the rest of these right now on your own. If you're feeling good, pause the video, try to work these out on your own, and then come back and we'll check the answers. I'm going to do these kind of quickly, but I'll write everything out. Here we go. I write out the raw formula. This will be negative 4 minus 1 over 5 minus negative 5. Negative 4 minus 1 over 5 minus negative 5. On the top, that will be negative 5. Down below, this becomes 5 plus 5. I'm going to simplify that further. That's negative 5 over 10. That simplifies to negative 1 over 2. Altogether, that's a slope of negative 1/2. All right. Moving on down here. Once again, I start with the raw original formula. It doesn't really matter what's 1 or what's 2, as long as you're doing one and then the other, and you're consistent. Okay, so I'm going to do negative 2 minus negative 3. Oof, that's a lot of signs. And then this would be, oh, I'm sorry. I should have labeled these. I should have labeled this one too. It's not too late to go back and clean it up. So we had y minus the other y. That's a double negative. Now we have the x minus the other x. I'm going to rewrite this. This becomes negative 2 plus 3. And this becomes 5 plus 5. Altogether, that becomes 1 over 10. That's a positive slope of 1 over 10. All right, -5, -3 to 5, -2. Good. Last one here, let's label xy, xy. Let's write the raw original formula every single time. We want to keep this format. Okay. So we'll do y minus y. That's going to be 5, take away -5, over -4, take away 0. I'm going to rewrite that as 5 plus 5 on top. -4 minus 0 is just -4. That becomes 10 over -4. I'm going to simplify that by dividing by 2, so that becomes 5 over -2. I feel like I saw that before in the previous problem. Ultimately, you pull the negative out front. This is -5 over 2, or sometimes you could rewrite this as -2.5 if you divide it into the decimal format. All right. Take a minute there. That is a lot. I don't expect you to get good at this in just one session. This requires practice, but I hope this has been helpful and gives you a framework for moving forward with good, strong habits. Let's move on. Here is a word problem here with a picture. How high above the canyon floor is Paul after 4 minutes of hiking? So let's just keep in mind here that every graph tells a story. What's the story here? The progress of Paul's hike at the Grand Canyon is shown below. How high above the canyon floor is Paul after 4 minutes of hiking? This graph shows hiking elevation. I see a line, it's going down. Looks like this is height above the canyon floor, and this is time. So he's starting at 360 feet. What story does it tell? He starts 360 feet above the floor, and then he's hiking downward to reach 0. Looks like this is a height of 0 in 18 minutes. So the question here is actually easy. How high above the canyon floor is Paul after 4 minutes of hiking? Well, here's 4 minutes. So we would go up here, that's right here, and we would get our answer is 280. The answer here is 280 feet. But really, that's not why I'm showing this to you. I'm showing this to you to really understand the negative slope. The slope here is -20. Let's write that out. The slope is -20. So what does that mean? That means he's descending 20 feet every minute. The line is coming down. And you can see here, every minute it's going down 20. 360 to 340 to 320 to 300 to 280. It's dropping -20, -20, -20, -20. The slope is -20. You'll notice this beautifully fits that format. Y equals mx plus b, where m is the slope, it's the multiplier. Every minute you go down 20 feet. So if I went 10 minutes, you would drop 10 times -20. That'd be dropping 200 feet. And you'll notice the starting value is at 360 right here. It starts at 360. Very nice. The slope is -20. Let's move on. Here we go. I love this. Excelsior Gym charges customers a one-time joining fee of $35 and then $50 a month. I'll write that out again. It is a one-time fee of $35 and then $50 a month, just in case it's cut off. A one-time fee of $35 and then $50 a month. So when they say $50 a month, they mean $50 every month. They mean $50 will happen repeatedly. Which equation can be used to represent the situation? So I need to see a one-time fee of 35 and 50 a month. All these 85s are tricks. It is not C and it's not D. This 85 is a trick. They want you to add these together and get tricked. No. We want to represent the whole situation a number of months. I want to see that 35 as a one-time. That means it's got to have the plus. It's just one time. $50 happens repeatedly. That's 50x. This is the answer. 50 times however many months you're there, plus your $35 entry fee. But what is the slope? Do you know? The slope is 50. It's 50 because 50 is the multiplier. It's 50 because 50 is the rate of change. Every month it goes up $50. The graph will have a slope of 50. Okay, great. Let's move on. This is kind of cool. On topic. Which of the following equations is not the same as the others? Well, none of them are exactly the same, but what's fundamentally different? Well, sticking with this concept of y equals mx plus b, we'll see that several of these have a multiplier of 8 and a one-time number of 14. But you notice this one, C, is different. This is the answer because it's different. These have a multiplier of 8. This has a multiplier of 14. These have a slope of 8. This has a slope of 14. Nice. All right, how about this? Here is a data table. Let's find the slope or the rate of change of this linear function shown below. So to do this, there's a few different ways. One is we could use the slope formula. Thinking of these as x's and these are y values, you could just use the slope formula. But another way to do it is that concept we said, similar concept of change in output over change in input. And now here, if we look, I see we have one, two, three, four different data points. All we need is 2 data points to do this. We have more than enough information. If we were going to use the slope formula, again, you just need 2 data points. So pick any 2 of these sets and run the formula. In this case, we'll just do whatever we see easiest. Here, I see this is increasing by 3. The output increases by 3 as the input increases by 2. Therefore, this is a change in output of 3 over 2. That's the slope. That's the slope right there, 3 over 2. You could make it a decimal, it would be 1.5, but I like it just like this, 3 over 2. You'll notice if I look here, it's increasing by 6, while this increases by 4. That would be 6 over 4. Following the rules of fractions, we can reduce this by dividing the top and bottom by 2, and we get 3 over 2. 3 over 2 is the slope. And if we really want to get sneaky, you could even do that for the whole thing. Like from 7 to 22, oof, that's kind of tricky. 7 to 22, that's a difference of 15. And from 4 to 14, that's a difference of 10. So that would be 15 over 10. Change in output is 15 while the input changes by 10. Reduce that fraction, you still get 3 over 2. Very nice. This is change in output over change in input. We also could do the slope formula with this. So we're going to write that out. Slope formula is y2 minus y1. It doesn't matter if it's 2 or 1 first. It really doesn't. And now here, we want to pick 2 sets of points. So I'm going to pick this one and this one. It really doesn't matter. So that would be 6, 10 and 14, 22. Now, we can't just plug these in as we feel like it. We got to be thorough. Label that X, Y, X, Y. So we need to put the Y values on top. I'll start with the larger one. 22 minus 10. I did this Y minus that Y over this X. I have to start down here now. Minus that X. 22 minus 10 over 14 minus 6. Y minus Y over X minus X. 22 minus 10 is 12. 14 minus 6 is 8. We got 12 over 8. We can reduce these as a fraction. 12 divided by 4, that's 3. 8 divided by 4, that's 2. And I'm still getting 3 over 2. Essentially, this graph goes up 3 for every 2. Okay. How you feel? Is it working? Here's another one right here. Which graph represents the equation 1/3 x plus 2? I love questions like this. Now, this tells us a few things. It tells us that the slope is 1/3. Please notice that immediately. The slope is 1/3. Let's just look for that. Slope is 1/3 means the rise is 1 and the run is 3. That means I want to see a graph that rises 1 and then runs 3 and then repeats rise 1, run 3. I want a line sort of like that. Do you see one here? I think I see it. I think it's A. Take a look real closely. Pick a clear point. That's a clear point. That's a clear point. That's a clear point. Yeah, I got a bunch of them. All right. Look how it's going. Up 1 over 3, up 1 over 3, up 1 over 3. That's it. That's the answer. Slope is 1/3. Beautiful. You'll notice also this +2 refers to the fact that it crosses the y-axis, the y-intercept at 2. This is the graph. That's it right there. While we're here, let's write some equations for the others. Come down for B. The answer is A. Come down for B. Let's write the equation. Well, it crosses at 2, so it's going to still have that +2. But now tell me, what's the slope? What's the slope? It looks like it's going down 1 over 3, down 1 over 3, down 1 over 3. This is a slope of negative 1/3. This slope is negative 1/3. Wow. Okay. How about this one? This one, I'm looking for clear points. Looks a little off. I'm going to say that that's at 0. I'm going to say that's crossing 0, and it looks like it's going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Rise 2, run 1. This one, therefore, the slope is 2. Positive 2, going up by 2. If we put that in the format, this would be y equals 2x plus 0. I say plus 0 because it's crossing right here at 0. You could, of course, remove that plus 0 because it's nothing. It's 0. And you could just write that's y equals 2x. That's this one. Very interesting. Right, just making a little space here. All right, let's do this last one here, D. Okay, it's a little off here, but I'm going to say, again, it's crossing at 0. I think this is the negative version. This looks like it's going down 2 over 1, down 2 over 1, down 2 over 1. Or here it would be like back 1 up 2, back 1 up 2, back 1 up 2. It's definitely negative. So this would be the slope is negative 2 over 1, which essentially is negative 2. So if I write this out, this would be y equals negative 2x plus 0 because it's crossing right here at 0. And you could simply write that as y equals negative 2x. Very nice, very nice. How are you feeling about this? This is pretty advanced stuff. Is it making sense? I hope so. If you're enjoying this video, please like and subscribe. Consider sending this to someone who would appreciate this content. All right. This will be our final question of this unit. This is a very challenging one that you often see in things like the GED test. Instructions are simply consider the two functions below. So take a look here right away. Is this two functions or just one function? Previously, I showed you stuff like this and I told you it's one function. You got a data table and you got a graph. This question is different. Look closely. First data point here is 0, 1. But look at the graph. 0, 1 is here. 2, 1.5, 2, 1.5, that's here. These are not the same function. This question is challenging because they're giving you one function in a data table and a different function in a graph. We are comparing them even though they are presented differently. Now, let's just look at these answer choices. What are we actually looking for? It says which statement is true. A. The rate of change of the function on the graph is greater than the rate of change of the function in the table. B. The rate of change of the function on the graph is less than the rate of change of the function in the table. C. The rate of change of both functions is the same. Or D. There's not enough information. I'll tell you right now, there is definitely enough information. First off, please remember, rate of change is the slope. So this is a question about slope. Basically, which one has the greater slope? The data table, the graph, or are they the same? Now, there's a few ways to do this. One way you could try to do it is you could try to plot these points and draw a picture. But if you're taking this on a computer, if this is a computer-based test or something like that, that might be hard to do. It might be hard to actually draw it out. That would work though. What I want to do right here is I want to get a numerical value for each slope. Essentially, what we need to do is find the slope of both functions. Once we have a slope for both, we can compare them and choose our answer. So let's start here with the graph because that's a little friendlier. If you have a picture, it's a little easier. I'm going to use the rise over run method. Rise over run. So pick any two clear points on the graph. I see a nice clear point here, and then I see some right here. And I see a pattern, nice steady pattern. To me, it looks like it's going up 1 over 2, up 1 over 2, up 1 over 2. Therefore, I would say the slope on the graph is 1/2, up 1 over 2. Okay, now let's come over here to the data table. We can try to do that thing where I said change in output over change in input, or we can try to use the slope formula. Let's do both. So right here, I can go, it's a 0.5. We could deal with that, but let's make it easier on ourselves. Let's go from 1 to 2. That's an increase of 1. And from 0 to 4, that's an increase of 4. I'm skipping the decimal because I don't need to use the decimal. If you had to use a decimal, we'd get in there. But since I've got some nice friendly whole numbers, pick the friendly numbers. So here I'm going to use the change in output over change in input method. I would say the output has gone up by 1 and the input has gone up by 4. 1 over 4. This goes up 1, this goes up 4. Here I see it again. If I skip this decimal, from 2 to 3, that's up 1, and from 4 to 8, that's up 4. 1/4. I think that's it. I think right here we could have our answer. We could be done already. But just to be thorough, I'll give you the optional method, which is you could use the slope formula. And to do so, I'm going to pick any two sets of points here. Again, I'm going to pick the ones that are have whole numbers because they're friendlier. So essentially, I have 4, 2, and I have 8, 3. I'm going to label those as x, y, x, y. I'm going to plug them into my formula, but first I'm going to write the formula, y1 minus y2 over x1 minus x2. It's essentially finding the difference in the y values compared to the difference in the x's. It's what we've already done, but we'll do it this way. So I'm going to start with this y value that's larger. It's a little easier. So I'm going to do 3 minus 2, y minus y, over x minus x, 8 minus 4. And I get 1 over 4. Okay, that's what we wanted to see. It confirms it. So, looks like the graph is 1/2 and the table is 1/4. Now let's just pick the right language. Don't get mixed up. The rate of change of the function on the graph is greater than the rate of change of the function in the table. Is that true? The graph is 1/2. 1/2 is greater than 1/4. Yes, it is. Half is more than a quarter. I think that's our answer. Let's just double check to make sure. B says the rate of change of the graph, the function in the graph, is less than the function on the table. No, that's not it. They're not the same. And we do have enough info. Correct answer is A. The graph is greater than the rate of change in the table. Lastly, let's try to plot the points. This might not always be available to you, so That's why I want to make sure you can do this. It's important that you can get a numerical value here. 0, comma 1 would be here. 2, 1.5 would be here. I'm graphing the data table now. 4, 2 is here. 6, 2.5 is here. And 8, 3 is here. It's a little hard to see. It's a little hard to see, but if we really broke that down, I think this line is a little less steep, which is what we're looking for. Very nice work. All right, here's one more question I want to throw in. You see this sometimes. Which of the following functions could be graphed as a line parallel to this? Y equals 3x plus 8. Parallel. Here's what I want you to think about. What's the slope here? Well, here, the slope is the multiplier. Therefore, the slope is 3, right? This is 3, the multiplier. That's the slope. Okay. What does it mean to be parallel? Write this down. Parallel, spell it right, spell it. Parallel lines have the same slope. Think about it. Two lines that are parallel are both sloping in the same way. So to answer a question like this, just tell me right now, which of these answer choices has the same slope? That's right, it's A. It also has a slope of 3. That's what we're looking for. These two lines, when graphed, would be parallel because they both have a slope of 3. All right, great job, everyone. Then we're going to wrap up our lesson right there. Thank you so much. I hope this has been helpful to you. Thank you to the person who requested this lesson. This is for you and everyone else. What do you want me to cover next? Leave a comment down below. Thank you. Please like and subscribe. Spread the word about the channel. Keep up the good work. Keep writing in your notebooks. Believe in yourself because I believe in you. Thanks, everyone. Have a great day.